So it's time to put everything all together here. And also, we might just see a little bit of weirdness happening. So today we're going to solve multi-step equations. They're going to have distributive property, variables on both sides, like terms. We're going to be showing all of our steps, and we're going to be checking our answers. So I'm going to start off with this map that I've mentioned before. Sometimes where students have trouble is knowing what to do when. So if you sort of follow this order, you can't go wrong. It's not the only way you can solve an equation, but it always works. So the first way would be to change subtractions to plus and negative for those folks that are getting lost in, is it a minus, is it a negative? Well, it's both. But if you see a minus and you change it to plus and negative, it kind of helps you to see what I call the arm of the number. The second thing is you're looking for parentheses, and to clear them, you're going to use the distributive property as we've talked about. Now, the third step here I've kind of made phased out there because we did not do it this year. To clear fractions or decimals, we did not talk about that, and don't feel a loss because you will talk about that in Algebra 1 next year. Now, the next thing you're going to look for, are there buddies? Are there like terms? Look on the left. Are there variable terms that can come together on the same side? Look on the right-hand side of the equals. Are there variables or constants that can come together like terms over there? Once you've cleaned up the left and the right, now, is there a variable term on the left and one on the right? And if so, we're going to collect those variables onto one side doing opposite operations. And then we'll end up with either a 1 or 2-step equation to solve using our steps, our inverse operations. And remember, we kind of go backwards through PEMDAS. So you actually look for the adding or subtracting to undo that first, and then you undo the multiplying or division. The Woodruff bubble helps with that. And then finally, you're going to check your solution, and you always check it in the original equation, and you use PEMDAS. You don't use distributive property. You don't use, opposite operations. You do the math on the left using parentheses, exponents, multiplying, dividing, or adding, subtracting, and then use PEMDAS on the right. So here I'm going to work through an example using the steps from the map that I just mentioned. So the first thing I'm going to look for is that minus. So I'm going to change that minus to plus a negative. I'm going to same, change, if you remember that language. So that's done. The second thing that I'm going to check for, are there parentheses? And there are parentheses, so I'm going to use the distributive property to clear the parentheses. 3 times the x, write it down, plus 3 times the negative 1. Write it down. And the x out here doesn't get that 3 because he's not part of the group. So you just write plus x equals 5. So there is after I do the distributive property. Remember that the next thing we kind of skipped over, and now we're looking for like terms. So here is our equals. Look on the left. Is there a pair of what I like to call buddies? And if you notice, I have 3 x's on the same side as plus x. We're on the same side. We combine them doing the operations that's there, the same operation. So 3x plus that 1x gives me 4x. The next thing I'm going to check for, is there a variable on the left? Yep. Is there a variable on the right? Nope. So I'm going to skip over that step. The next step is to solve either our 1-step or 2-step equation, which is what we have here. So you can Woodruff bubble, find that variable and what it's attached to, and make your no-fly zone. Now you look outside the bubble, and you need to make a 0 pair, opposite operations. You're creating a 0 pair, adding a negative. It would be subtracting a negative, but subtracting a negative is adding 3. You need to combine a number with this negative 3 to make a 0. So our step is going to be to add 3. See the 0, guys? Negative 3 and 3. We didn't touch the 4x. We have 4x plus 0, which is 4x. Write down our equals, and 5 plus 8. 5 plus 3 is 8. Got ahead of myself there. Okay, now the final step is that there is the invisible dot. There's 4 times x. Now this 4 is going to the opposite side. I need it away from the x. So I'm going to do the opposite operation, which is to divide by 4. and 8 divided by 4 is 2. That was a lot of steps in there. Did we get the right answer? Now, when we go to check it, that 2, yeah, I mean, it'd be really cool to put it right there and say, oh, 4 times 2 is 8, yay! But you didn't check all the steps in between. So you're going to put the 2 back up in the original equation in for every x that you find. And then we are going to do our math. So I just wanted to show you that that's where it came from. We're going to do our math, but we're going to forget that we do distributive property and all that. We are going to use PEMDAS. So we're going to look in the parentheses first, and 2 minus 1 is 1. That was easy. So now I have to take 3 times that 1, which would be 3, and then finally I add the 2, and I get 5 equals 5. Mrs. Woodruff, why don't we use distributive property in the check? I'm going to be honest, if you mess it up here, it's very likely you're going to mess it up down here, and you won't catch a mistake. So if you always use your order of operations in the check, you're doing something different to kind of check what you did up above. All right, so it's kind of your turn. There's really nothing new here. So I've kind of given you some clues along the side. So the video is going to pause. You're going to start by changing the subtractions. Then you're going to do the distributive property. You're going to combine like terms, and then there'll be a two-step equation. It looks a lot like the one we just did. So give it a go and come back and we'll walk through it. All right, there's changing those subtractions. And if you want to slide that invisible 1 in there, that coefficient that's missing because mathematicians are lazy and don't write it, you absolutely can. Okay, so there was the changing that minus to plus a negative. Same change. Now we're going to do the distributive property. Negative 3 times 5 is negative 15. And a negative times a negative, a bad thing happening to a bad person, is a good thing, and it's plus 3t. Now you go to Woodruff bubble. Wait, no, we can't Woodruff bubble because there are like terms. They're on the same side. They're both on the left. So we don't do opposite operations. We just smush them together. We just add them. They're buddies. And 8 plus 3 is 11t. Is there a variable on the left and the right? And the answer is no. There's no t over here. It's just the constant 18. So we're at a two-step equation. Okay, get your eye on the variable. And don't touch him in the 11. Okay, don't touch that. And you need to make a 0 pair with this guy. You need to do an opposite to get this to be 0. So it would be adding 15. You're creating a 0 pair. If you put minus 15 here, you're getting negative 30. Okay, so the opposite of adding a negative would be subtracting a negative, but subtracting a negative is the same thing as adding. Okay. I think it's easier to just look at it and create the 0 pair. And if you do it here, you better do it over there. This is 0 plus 11t, which is 11t, and 18 plus 15 is 33. And you got a calculator. So if you're making some silly, addition, subtraction, division errors, check yourself with the calculator. And finally, this is the invisible dot for multiplication. So the opposite, to get the 11 to go to the opposite side, I need to do the opposite operation, divide by 11, and I get a 3. And I'm really not feeling that confident in that because there was an awful lot that happened. So I'm going to check my answer by putting the 3 back up into the 2 t spots up above. And I'm going to check, and the way I'm going to check it is not to do distributive property, not to do the rainbow, but to simplify what's in the parentheses, the p first. And by the way, it's easier. 5 minus 3, I don't need a calculator. Negative 3 times 2. And now I'm going to multiply negative 6 plus 24. And does it equal 18? And it sure does. So that t equals the 3 is the only number that can go into this original equation. And all the math get done, and it equals 18. Okay, so how about one on your own here, number 2, and we'll come back and see how you did. Distributive, well, first of all, did you can change this minus or not. That's what I wanted to say here. So what I have found over my years as a teacher is about half the class likes it as plus a negative, and half the class likes it as a minus. I meant to tell you that. So I kind of did that here. 6 times y is 6y. 6 times 4 is 24 plus a negative 2y, or you could have written it as minus 2y. I don't count that for points because really half the population likes it one way and half likes it the other. Look here, a 6y and a negative 2y, same side. So we're not going to do opposite operations. We're just going to put them together. They're like terms, and we get 4y. 6 and a negative 2 makes a positive 4. And here comes the Woodruff bubble. Subtract 24 from both sides. Divide both sides by 4. And did you get negative 8? Now, if you need to pause the video right now to fix yours, please do. Alrighty, we're going to put that back up in the 2 spots up above. Going to do PEMDAS. So I'm going to take negative 8 plus 4. I think it's negative 4. I'll check it in the calculator, and I'm right. Now, over here, a negative times a negative gives you a positive. And if you need to change that to plus a negative to see that, you know you can do that. The same change idea. And 6 times negative 4 is negative 24, and negative 24 plus 16 makes me a happy girl. Okay, so let's walk through the next one together because I notice it's gotten a little more complicated on the right. Okay, what's the first thing I'm going to do? Well, I decided to change those minuses to plus a negative, so I same, change, changed. And where's the other one? Right here. I same, change, change, okay? Okay, what's the next thing I notice? Parentheses. It looks like a mess, but just get your eyes right here. We are not going to take 5 plus a negative 3. We can't do that. We have to do distributive property first. That's multiplication. Distributive property is multiplying before you add, okay? So the 5 plus is just going to come down. But negative 3 times 2p is going to give me a negative 6p plus negative 3 rainbowed over times 1 is negative 3. So my distributive property is now shown on the screen. Whoops, let me get off that so it clears up. Okay, now just look at the left. There's got to be a pair of buddies here. This time it's the constants. I got a 5 added to a negative 3. They're buddies. They don't have p's, so they can come together. What's 5 plus negative 3? Think it. Did you say 2? You can always check it in the calculator. And there is my next step. Okay, now the next thing on the map was, is there a variable on both sides? And the answer is, yep. There's a negative 6p on the left, and there's a negative 3p on the right. So this is usually where we talk about having a choice. You know, can you go to the left to go to the office? Can you go to the right to the office? If you were in class the other day when we were talking about 2 ways to get to the office, there's 2 ways to solve this one. So make a 0 pair with this guy would have to be a plus 6p, right? Plus 6 and minus 6, they're going to come together as a 0, or plus 6 and a negative 6, same idea, makes a 0. So we're going to add 6p, or you could come over here and make a 0 pair and add 3p. Now I'm going to guess I added the 6p because I tend to be positive. Let's see, and I did. Why I say that's positive is when I add that, this is going to make a positive coefficient. All right, so let's go across and say the 2 didn't get touched. 2 plus 0 leaves a 2 on the left. And over here, we didn't touch the 8. And 6 and a negative 3 added together will give me a positive 3p. And I like that way because I don't have to worry in a minute about having a negative in front of the p. All right, time to Woodruff bubble. You see it? You're going to circle that 3p. Now, look outside, the opposite of adding 8, or think about making a 0 pair, we're going to need to subtract 8 to get that 8 to be a 0. Now over here, 2 minus 8, think your answer, check it in the calculator, should get a negative 6, and 0 plus 3p. We're down to a one-step equation. And the opposite of multiplying by 3 would be to divide by 3. Whew, finally got there. Wow, negative 2. Now the check is going to be almost as nasty as the problem. And we're going to put a negative 2 there, and we're going to put a negative 2 there. So I'm going to work inside the parentheses. 2 times negative 2 would be negative 4. Negative 4 plus 1. Oh, by the way, a negative times a negative is a plus 6. That's kind of, you have to work both sides using PEMDAS, right? Sometimes it's easier to do one and go back and do the other. Still in the parentheses, negative 4 plus 1 is a negative 3. A negative times a negative would be a positive, and the other side worked out to be 14. So it did work. Our answer is negative 2, but man, the check, I think, is worth more points than just 1 this time, right? So that is about as rough as it can get. And if you remember back quite a few weeks ago when there was a big picture of me with a face slap telling you, why, Mrs. Woodard, do I have to show the steps? I kind of showed you one that looked like this. And guess what? We just solved it. Okay, so I promised you at the beginning that there would be some weird results. So I'm just going to show you 2 more problems, and then it's time really to just get practicing. There's no more new stuff after what we're going to talk about right now. So here is an equation, and I'm going to solve it. And I notice that, I have a minus here, so I'm going to change it. And over here, the minus, I'm going to change it. And I slipped in that negative 1 coefficient, the invisible 1. All right, so the next thing I'm looking for is distributive property. Not going anywhere there. But on the right, there is a pair of like terms, 7m and a negative 1. They're on the same side, so you're not going to do opposite operations. You're kind of almost ignoring what's going on over here, just looking on the right. So you're just going to smush them together. 7m, take away 1m. So if you have 7 m's and you take 1 away, you'll end up with 6 m's. Now, before we go any further in talking about the variable on both sides, I just want you to notice something. So we got a number, some number. We don't know what it is yet. We're going to multiply it by 6 and basically take away 5. And it equals that same number times 6 again, added to 7? How can that be? Now, if you don't see what I'm talking about, let's keep solving our equation. And the next thing would be, is there a variable on both sides? And there is. And do you notice there's no choice? Usually we have a choice. The only choice we have would be to subtract 7m from both sides. And when we subtract 7m from both sides, we're going to get negative 5 equals 7. But let me just show you kind of what I'm talking about. There is a variable on both sides, but you don't have a choice. And when this happens, you look closer, you can see it's an impossible situation. You can't take a number, let's just say it was 1, and multiply, you'd have 6, take away 5, and over here you'd have 6, add 7, and they're equal. There is no way this situation can ever happen. So basically, when you solve an equation and reach an impossible situation, the solution has no solution. No number works. So no matter what m you pick in the first equation here, but I should say the original equation, it doesn't work. Nothing. No solution. So you mean there's more unusual results? Well, let's check this one. So this time, once again, I'm going to change, change. Okay. That becomes plus a negative, and that becomes plus a negative. Ooh, I see some parentheses over here. So I'm going to do the distributive property. 2 times 5 plus 2 times negative 4. So there we are. Oh, now look at this one, guys. Look at the left and look at the right. They're identical. Exactly the same. So basically, if you look here, you're going to take a number, multiply it by negative 8 and add 10, and it equals the same number times negative 8 plus 10. I mean, what is unusual about this result? There's a variable on both sides, but again, you don't have a choice, right? Your only choice would be to add 8a. Both sides are identical. And basically, you could put 1 in for a and it would work. You could put 2 in for a and it would work. And you could put 3 in for a. Like any number is going to work. So here's the big idea. When you solve an equation and you reach an identical situation on both sides, that's called an identity. And it means that every number works. So let's just talk about these two kind of weird things here, okay? So the first one is a no solution, and it's an impossible situation. You end up not having a choice like this, or you end up with something like this when you're solving that's impossible, no value will make this equation true. And this is called a no solution, but there's other symbols. I don't know if you've ever seen this symbol in elementary school. It's called the null set. So you could call this one no solution, 100%. You could call it the null set, or you can make this kind of a O with a line through it. The second weird one is called the identity. This is where you end up with an identical situation on either side. Could end up looking like that, or it looks like this. And that is called identity, or you can also put that funny R, and it's called all real numbers. So the word identity and that R and all real numbers, they're all synonyms. Any one of those is good. And up here, no solution, that symbol in the null set, doesn't matter. Any one of those are saying the same thing. Now, here's the cool thing. You can't check them. You can't check every number down here rather. And up here, there's no number to check. So students often like the special cases because it takes that check out. So today we were just, making our equations more complicated. I think if anything, over the last couple of weeks, we have learned how important it is to do the steps because boy, our equations are pretty complicated now. And give yourself credit for sticking in there with some pretty tough equations. When I see you next, it'll be time to practice. So guys, have a great day. See you soon.